All right. Moving on to chapter 6. Any questions before we get started tonight? All right, chapter 6 is about I/O streams in particular and objects and classes in general. So we're going to start off talking about streams, which are basically a flow of data. In here, that data is going to take the form of characters. It's all human readable data, but you can have streams that are binary data that's harder for humans to read. And there are two types of streams, input streams and output streams. And we've actually already been using streams. I think I mentioned when we first started using CIN and COUT that they're actually stream objects that connect to system resources. So CIN is actually the system input stream, which is a standard input handle that gets handed to our program by our operating system whenever we start running. And COUT is the standard output stream handle that gets handed to us, to our program when we start running by the operating system. And so those are just ways of accessing those, but we're also going to be using streams to do file I/O. So it's all very well and good to get data from the keyboard and display data to the keyboard, but there will be times when it's important to have our data be more permanent. So we want to get data from files where we've accumulated a lot of data. We don't want somebody to have to sit there and type in all the data we need. And we want to be able to store the output data in files so that it can be reviewed at leisure or assembled into bigger, more cumbersome pieces of information that are then going to be processed in another way. So let's talk about file I/O. So when we get data from a file, we say we're reading that data. When we send data to a file, we're said to be writing that data. And in C++, we're going to refer to a data stream as just another variable. It's a type of variable called an object because those streams are implemented as classes, and the instance of a class is an object. So we're going to have input file streams, or IF stream, and output file streams, or OF stream. And in order to use those file streams, we're going to need to include the fstream library. And we're again going to be needing the std namespace because that's where IF stream or OF stream are defined. But we can't just have a variable and start sending things to it or getting things out of it. We first have to connect that variable to an external file, or in other words, open a file. And so the file or the input file stream has an open member function, and the output file stream has an open member function. And those functions serve the purpose of connecting the external file to the internal file.
Does it make the file, or do you have to make it prior to?
If you're opening a file for output, it will create it for you. If you're opening for input, it will expect it to be there. Now, there is a way to open a file for output with append. We'll talk about that a little bit later. If you don't choose to append and you open a file for output, any file by that name that already exists will be overwritten by your new file. At the bottom of page 310, they talk about the two names of a file. And the two names are the external name. That's the way we refer to the file at the operating system level, external to our program. And the other name is the internal file name, and that's the name of the variable that we're connecting to that external file. When we get through with our file, we're going to close it using the close function. Basically, that tells the operating system we're through with the file. We want to make sure all of the buffers that we have written to our output stream go into that file, and then the connection is severed, and the operating system no longer treats that file as being connected to our program. So those are the basic steps. We create a variable that's an IF stream or OF stream. We open the file using an external file name as the argument. We can then input data into the files, into our variables from the input file stream using the extraction operation. And we can output data out to the output file stream using the insertion operation. And then once we're through, we close the file, and the output data becomes permanent. It'll stay there until somebody deletes it or overwrites it. And for an input file, we're done using that file. So I've mixed a little bit of class and object terminology, and let's look at that a little further now. The IF stream is declared as a class in the FStream library. When we declare a variable of a data type that's a class, that variable is an object. When we want to call a function that belongs to that object, we use this dot notation. And we have the calling object in front of the dot and the member function following the dot. And then we have 0 or more parameters that we need to fill with arguments.
The file, does it have to be in the same level as the program? Like,
So Windows will allow you to have a fully qualified path name here. So I could say C:\\, PT, \, and so forth. If I don't include all the path information, then it expects it to be in the same folder that I'm running from. So when I'm running my program in debug mode, that folder is going to be the debug folder. That my source code, or my source program file is. So if I open the containing folder here, so if I run this in debug mode, it's going to expect my file that I'm trying to open to be in here. And if I create a file, it'll create it in here. If I compiled it and then ran it separately, then it would expect it to be where the executable file is. So if I just ran this executable file, then it would be looking in this folder for a file, or creating a file in this folder. So that's when it would go in the debug folder, because that's where the executable gets compiled to when we're in debug mode.
so in the same sense, when it makes, if it's making the out file, not DAC, it's going to do it in the debug folder.
Well, it's going to do it in debug mode. It's going to create it in the project folder.
Project. Okay.
If you've compiled it and you're running the compiled version, it's going to run it wherever you're running the compiled version from. So if I started a command line and I said, I gave it a fully qualified path to the executable file, and I ran it here, then it would go in my current active directory. Does that make sense? Every time you run something in Windows, it has a current active directory that's associated with that program. And unless you do something specifically to change that, Windows is going to assume that's where you're putting something if you don't fully qualify it. All right. We're not quite done because we discussed the possibility that that file might not be there that we're trying to open. And if it's not there, we don't want to just have our program crash. We'd like to know about it and do something a little more graceful than just break, and the user has to figure out what went wrong. So there's a function to tell us if something went wrong. That's the fail function. And you can actually get more sophisticated than just calling the fail function and quitting, but this is the minimum that you need to do. If you try to open a file and fail returns true, then something went wrong while you were opening that file. And you need to do something about it. In this case, they are quitting the program with the exit function. And in order to use the exit function, they had to include the cstdlib library. You'll notice the exit has the number 1 with it. That number will actually get passed back to the operating system. So if a batch program is controlling your program and it gets something other than a 0 back from your program, it knows that an error occurred. So, one more step. After you open the file, check to make sure that it actually indeed opened, and then proceed. And there's a summary on page 318 of all the file I/O statements, so you know what you're doing. All right, self-test exercises on page 319. Sandra, we'll start with you. Let's see, number 1. You're writing a program that uses a stream called fn. It's going to be connected to an input file. And a stream called fout is going to be connected to an output file. How would you declare those, and what include directives, if any, would you need in your program?
You'd have to include upstream.
Okay, include upstream. And to declare your 2 files,
It'd be in-stream,
I
I_stream.
okay,
Should be the FIN stream.
is the class called InStream?
No, that was file, excuse me. Fstream
IFstream, okay,
Yeah.
input file stream,
space FIN
okay.
semicolon.
All right, there's our input file stream.
And it'd be OF stream
OF stream,
space FOUT.
F out, okay. All right, Mr. Nelson. So we're going to continue. You want your program to take its input from the file stuff1.dat, and you want it to send its output to the file stuff2.dat. What statements will you need to connect your streams to external files, fn to stuff1 and fout to stuff2.dat, and make sure that they actually open successfully? What do you need to write now?
Need a FN dot open.
Okay.
From stuff one dot net.
So open parenthesis, double quote, stuff one dot DAT. What comes
Then
next?
we need to check to see if it failed or not.
Okay.
So that'd be if FN dot failed, the parentheses, close parentheses. Say cout. The file failed to open. And say exit, parentheses one.
Okay. What comes next?
And switch the data. I don't know.
Oh, we need to do the same thing for F out, right? Need to open it, put the correct file name, and check to make sure that it worked. All right. Mr. Rahim, you're still writing this program. And we did some stuff here in the middle. Now we're done with our two files. We no longer need input from stuff one, and we no longer need to send output to stuff two. How do we close our files now?
BFN dot close.
And F out dot close. Okay. Ms. Hernandez. Number 8, name. Oh, no, not 8. What was it? Oh, number 9. Name at least 3 member functions associated with an IOStream object and give examples of each one. And it says IOStream, but I think they probably mean FStream. We've been talking about files. So let's just say FStream there instead. So what are three member functions that we just got through going over?
We did the open,
Open, okay,
and then the
close,
close,
and fail, okay. And what would be the examples? How would you use those in a program?
what we just did.
Okay. Can you explain it to me in words?
Check the files, input and output.
Okay, open does what?
Opens the file.
Meaning, so, all right, so let's pay attention. It's connects our internal file name to an external file. So that external file name that we pass it as an argument is the file that it's going to connect to at the operating system level. So when we send something to that file, it goes to the file that we named in the open function. When we retrieve something from that variable, we're retrieving it from the file that we connected to in the open. All right? Close does what?
It verifies that it was used.
Okay. So it flushes the buffers, and it disconnects it from the operating system. So it's no longer, there's no longer an association. And fail does what?
If you had errors.
Tells us if we had some kind of an error with our most recent operation on that file. So what we're using it for right now is to tell us if our open failed, but it actually will return true if any kind of an error happened in any operation on that file. All right? Mr. Brantley, a program has read half the lines in a file. What must it do to enable reading the first line a second time?
You open the file and then when you're done reading half, you would close it. Then you would open the file again.
Okay, yeah, that makes sense. Unfortunately, I have found that that doesn't always do that in Visual Studio. So in addition to doing a close, I am going to tell you that, at least in my experience in Visual Studio, you will also need to do a clear to reset the pointers and return you back to the beginning of the file. So close, clear, and then open it again.
So the, for example, like F in clear
Right.
dot.
Fn dot close with empty parentheses, Fn dot clear with empty parentheses, and then Fn dot open to reopen it and start at the beginning again. All right, and Mr. Gear, we just talked about how a file has two names. What are the two names and when do we use each name?
Must have missed you talking about that.
Okay. Does anybody remember that?
External is the file. in the
Okay.
computer, And internal is the file name and our variable in the program.
All right. So the external file name is the name as it appears on the operating system. The internal file name is the name of the variable that we're using to refer to it. And when do we use those two names? Anybody?
We want to open the file or call it, and then we want to use it within the program.
Okay, which name do we use and when?
The external would be when you're calling the file, the internal would be when you're using a variable name in the program.
Okay. So anytime we refer to a file in our program, we're going to use the internal name, whatever we're doing. When we're declaring it, when we're opening it, when we're doing I/O, getting data into it, sending data out, getting data in from it, sending data out to it. The only time we use the external file name is in the open function itself as an argument to that open function for the internal file. That establishes the connection to the external file through the operating system. And we can then, any operation we do to that internal file happens to that external file because of that connection. But that's the only time we use the external file name. All right, well, 6:40, let's take a short break and then we'll resume in 5 minutes or so.